Hi y'all, this is just a couple of problems from section 2.1 where we're asked to classify different types of ordinary differential equations. So we're just going to look at number 1 and 2 here. And so the first thing that we're going to look at is what is the order? And recall the order always refers to the degree of the highest derivative. And so in this case it's a first derivative, so for the number 1, the order is simply 1. And then we're asked to check whether it's linear or nonlinear. And recall, by linear, we are really asking if it is linear in y. And so another way of saying that is we want to make sure every derivative of y, it could be a higher derivative, but it just shows up by itself. So we don't want y prime times y. We don't want the second derivative divided by the first derivative, anything like that. So for the first problem, the derivative is okay. But notice there's a y squared. I actually don't mind that there's a t involved because that's the independent variable, not an issue. But y squared, well, y, being our dependent variable, shouldn't have anything happening to it that would be nonlinear. So squaring is nonlinear, and so this is a nonlinear equation. And if the equation is nonlinear, well then you don't ask if it's homogeneous or non-homogeneous because that refers to linear equations. And the coefficients, we don't care about that either since those are really as well defined in terms of a linear equation. So then we can just move on to number 2. Number 2, looking at the degree, we look at the highest order derivative, and so this is a first order, right? Just kind of like the Star Wars movie, so order 1, or first order, and there is a t multiplying by it, but that doesn't actually matter since t is our independent variable. It can do whatever it wants. Now we ask, is it linear or nonlinear? So we look and see, well, the derivative of y doesn't have any other y terms with it, and the y term is just y. It doesn't have even any coefficients, but most importantly, it doesn't have y squared. It's not sine of y, it's just y. And so because of that, this is in fact a linear equation in y. So then we could ask if it's homogeneous or non-homogeneous. Well, there's a function of t hanging out by itself over there on the right hand side, and so this is non-homogeneous. Recall homogeneous just means when you write it in this form you have a 0 on the right side. And are the variables constant, or sorry, are the coefficients constant or variables? Well, this is a constant coefficient, but there is a t multiplying our derivative, so they are variable coefficients. So there is a classification.